So we're going to take it right the way back to the roots, and we'll actually discuss what is data. So not even what is a database. What is data? What is that? In terms of what we do, what is data? So going through my notes here, data is a collection of facts or statistics. Computer data is information that has been translated into a format that can be stored, transferred, manipulated, and consumed by computer processes. And I've got some examples here. An example of data could be, say, a person's age, a person's name, a weight, or eye color. These are factual information about a person. So data represents a collection of facts or statistics, and computer data is information that has been translated into a format that can be stored, transferred, manipulated, and consumed by computer processes. That is essentially what data is. At the most rudimental level, computer data is made up of a sequence of ones and zeros, which is known as binary data. Now, I'm going to do an explainer video like this on binary data at some point, but not today. Just know that from the very lower levels of a computer process, it's going to see the data that you input, however you input it, as zeros and ones, as binary. Okay, so when a computer is processing the data, their values will get categorized into different data types. For example, the person's age might be an integer value, their name and eye color could be a string, and their weight could be a floating point. Say if it was pounds and stones or something like that. Okay, so from the binary data level, and we won't talk too much about binary data because I don't want to overly go down many rabbit holes. I just want to focus really on databases and data. But from a binary level, you have the ones and zeros, and then you've got several layers above that the computer then interprets that binary into various different things, and that out pops a type of data, be it an integer value or a string or what have you. That is what we then use as a programmer to say, oh, this is an integer value, this is a whole number versus this is a string or this is a floating point, So that is what data is. So what is a database? What is the base of the data? A database is used to organize structured data, allowing for the management and manipulation of data. Now, you may think, well, that's quite obvious, Pete. A database is used to organize the data, right? Sure, because it holds the data. It's the data store. And then, obviously, it gives us tools to manage it. But the key word there is structured data. So a database is used to organize structured data. And we're going to be poking that hornet's nest of what that structured means in a minute, allowing the management and manipulation of data. Normally, a database holds the data in a series of tables, rows, and columns. Let's go back to the person example. So the person example, we could have a table called person. And in that table, we could have columns or fields that represent something to do with that person. I.e., for example, we could have a column of age. We could have a column of eye color. We could have a column of weight, and so on and so forth. When we pull back a row, we're pulling back the columns within that table. Okay, so let me just say that all again. A database is used to organize structured data, allowing for the management and the manipulation of data. Normally, a database holds the data in a series of tables, rows, and columns. These can be indexed so that the relevant data can be queried efficiently. So we could index some of the data. If we know that some data is more retrieved than others, right? Based on various different queries, and we'll talk about those in a minute, right? Then we could index these things. So for example, if we know that a person in the persons table, if we know that that person is unique, right? So that is a unique person. We give that person a number, which is called a primary key, perhaps. That is a unique primary key that is related to that specific person. And that unique identifier cannot be used again because it is unique. Therefore, we should be indexing that column, the ID, the identifier. It is a primary key and it is also unique, right? Therefore, we can index it, which means that the queries will be returning better when we're saying find the person by the ID of 10 instead of find the person that has the name of John and the eye color of blue, right? That's probably actually going to return you several people rather than one person that has the unique ID of 10. Okay, so when a database query is made, records containing the data are returned. A database record is a collection of data which is organized into a group of fields. So a database table has a number of fields which correspond with corresponding values, yes. As an example, a person's name, age, weight, and eye color could be a series of fields held within a database table. So when a database query is made, records containing the data are returned. A database record is a collection of data which is organized into a group of fields. So a query could be made to return all the names and weights of people that have the eye color of green, for example, which means that you're going to exclude anybody that doesn't have the eye color of green, and you're just going to return the records of the people that do, right? And you're going to limit that query to return only the names and the weights of the people who have the eye color of green, all right? So you're not worried about the age or anything like that, which means that you can create these queries in a very flexible manner. Yeah. Okay. So one of the biggest questions that I have seen on the internet, and also one question that I have asked myself a lot and got very confused over the answer with when I was starting out, was, is Excel a database? Is an Excel spreadsheet a database? So even though Excel can store data, it is not a database. Excel is a spreadsheet which stores data in a cell or cells, right? So you have individual cells that you can put data in. This data can be formatted, edited, and controlled within that cell. A database, however, has records that contain data that come from external tables. That is the key, that is the clincher. So a database will have multiple tables, and a spreadsheet will just have a spreadsheet with various cells on that sheet. This means that Excel is technically a static document, while a traditional database is relational. So we've explained what data is, okay, and we've explained what a database kind of is, and we've explained that Excel isn't a database. But now we've hit this thing where I've said this means that Excel is a static document whilst a traditional database is relational. What on earth does that mean? A traditional database? So that means that there's databases that aren't traditional? And why did I say relational? Okay, so before we get to the relational stuff and the non-traditional databases, let's first talk about something that I mentioned earlier on, and that is a database management system. What is that? So a database management system, or a DBMS, is an interface between the database and the end user. Okay, a DBMS allows the end user to perform operations and queries against the database. An example of this would be MySQL, Microsoft Access, and an Oracle database. So these are DBMSs, all right? These are management systems that allow you to manage the data as well as the database. You've got to make that distinction. There's two separate things there. The database itself has configuration. The data has configuration. The database will need to have various different configurations to allow access to users and to permissions and grants and all of that jazz, locking people out of tables or only allowing certain people, read access, write access, that kind of stuff. Also, the database management system will allow the use of various monitoring tools, right? So you could use that to monitor the database, keep integrity of the data. Database management systems are essentially the front door to the database. It's the connection, if you will, between your app and the data. All right, so a database management system, or a DBMS, is an interface between the database and the end user. A DBMS allows the user to perform operations and queries against the database. This could include data insertions, data updates, data removal, and database schema changes, as well as data querying and formatting. Whoa, database schema, that's another one I've thrown in the mix. We will be talking about database schemas at some point, but right now don't worry too much about a database schema, what that means. We're focusing on databases at the minute. Okay, a DBMS also maintains the security of the database by handling users and permissions. This is what I was rabbiting on about earlier, about the various grants and the permissions and the read access and the write access and that kind of stuff. Now we've discussed what a DBMS is, we can now talk about what a relational database is. Remember up here I said, when we were talking about Excel, I said this means that Excel is a static document, whilst a traditional database is relational, and I just kind of left it there like some weird cliffhanger. So we're now going to talk about what a relational database is. The way I've structured this, by the way, is I've tried to talk about one thing whilst not getting too in the weeds, and sort of like laying out the foundations before I start digging in any deeper. So now we know what a DBMS is, we can now talk about what a relational database is, because there are non-relational databases and they have their own DBMSs. So a relational database organizes data in a predefined structure and a series of relationships that connect data together. The database will have multiple tables and will use keys to connect related data together. This reduces data redundancy and helps with data management. So let's just pull that apart for a minute. So the database will have multiple tables, sure, yes, okay, and we'll use keys. Now I mentioned this before, primary key, for example, when we were talking about the person table, to connect related data together. So related data could be data in different tables, for instance. So we're saying this table can be joined with this table based on these keys. As an example, our database may also contain a table called medical notes. Each record in this table will be connected to a record in the person table via a key. A query could be made to return the latest medical note that was made against a person with a certain name. Okay, so imagine, if you will, you've got two tables in your database. One is person and the other one is medical notes. So you'll have various different notes per person. Okay, so a medical note is connected by a person. You may have, say, an ID in the person's table, and you may have the corresponding ID connected to that to various different notes. So a person may have 20 medical notes or 10 medical notes or even one medical note, but each of those medical notes will have a ID that corresponds to the ID of the person. All right. So when you're connecting the data together, you're saying, find me the person first. Okay. So this person has the ID of 25. Brilliant. Okay. Now find me all the medical notes that are related to the person that has the ID of 25, knowing that that is a primary key and it's unique, which means that no other person will be having that ID in the medical notes. So I am confident to say that all the medical notes that get returned with the person ID of 25 relate to that person. There we go. We've made a connection. We have made a connection between the tables. As the medical notes and the person details are separate groupings of data, they are stored in separate tables, different tables. The medical notes table would have a field that identifies the connected person. This field would be typically an incremental integer, which corresponds to a unique identifier in the person table. The connected field will be related via a key, which allows for efficient storing and querying against the fields in both tables. For example, you could say, find me all the medical notes where that person has the ID of that person. You could do that. And it will find the connected fields that relate via the key of that person, the person ID being the key there. Okay, so I used a term somewhere along the line of structured data. And I've also used the term SQL a lot when I was talking about MySQL and MS SQL and Postgres SQL, right? So what is SQL? Well, SQL means structured query language. A relational database management system, RDMS, relational database management system, will use a structured query language, SQL, to manage the data. SQL comes in different flavors depending on the type of database management system used. MySQL is an open source RDMS, whereas MS SQL is Microsoft's version of an RDMS. Okay, so there are the structured query language is used for a relational database. So if you are using a database, MySQL, MariaDB, MS SQL, Postgres, you know that you're using a relational database because you are using structured query languages. And this is the whole point around relational databases, is the structure. You are giving structure to the data. You are defining the data and how the data relates to one another. Database engineers and administrators can use SQL to integrate with the data held in the database. Typically, this is done in the form of queries or stored procedures. The queries performed by SQL are usually the following. So an update. It is existing data is updated. Insert. New data is inserted. Delete. Existing data is removed. Or a select, where records are returned based on the supplied query. SQL also allows for the management of data definitions, the data schema, and access control. We've talked about relational databases. We've talked about structured query languages. Heck, we've even talked about what data is and what a database is, okay? What we haven't talked about is what non-relational databases are. What is NoSQL? NoSQL. What is that? So a non-relational database is sometimes referred to as NoSQL. This is because the data is not structured and does not have any defined relationships. Examples of NoSQL include MongoDB, Amazon DynamoDB, Redis, and Couchbase. There's various different types of NoSQL, like there is various different types of SQL, right? So with NoSQL, you could have, say, key value pairs. You could have cache. You could have documents and all sorts of various different crazy types of NoSQL. We won't go into those specifics today, but just know that there are a few different types of NoSQL databases, such as value, document, and even graph, right? As the data is housed in a single data structure, there are some advantages over traditional relational databases, such as rapid scalability, data flexibility, and high availability. Okay, so whoa. What did I mean there by saying as the data is housed in a single data structure? Well, when we're playing around with SQL, we have multiple data structures, right? Because we have multiple tables, and each table has its own structure, its own defined set of rules. You know, there must be this field, and it must not be null, right? or this field must be an integer, or this field must be a date time. Or we could even have rules that say every time a new record has been inserted into this database table, we automatically update the created date field. Or likewise, if a record was to be updated, we automatically update the updated by field. That kind of stuff, those kind of rigid rules. And we're saying that this person can only have this set of medical notes, or these medical notes can only be related to this person, right? Really rigid, kind of hard and fast rules, which you need for those kind of examples. You certainly don't want to be playing around with NoSQL when it comes to people's medical notes. You certainly don't want to be playing around with NoSQL when it comes to user access and logins. You want rigidity. You want the ability to actually enforce these boundaries of the data. When it comes to NoSQL, all of that goes out the window, which is why when I started learning how to do this, it was like, hang on a minute, this goes against everything I know. This is so weird. But if you think about it, there are various different things that NoSQL offers that relational databases don't. So, for example, real-time tracking. I'll use an example. Deliveroo or Just Eat or any kind of delivery service like that, they will tell you. And I don't know if they use non-relational databases for sure. I certainly know people who work in those companies, but I've not asked them this. But an example I could possibly give, I'm speculating a little bit here, where they could use NoSQL is around the delivery section. So when when you've made an order and you're looking at the little person on the bike on your app, on the mobile app, right, and it's updating, and you refresh and it updates, and you refresh and it updates, and it gets a little bit closer to the front door. Those kind of GPS markers don't need to be, in my opinion, stored in any kind of relational database. There's no point there, because it's a set and forget, or you set, forget, and remove. Like, there's no point in keeping that data around, right? It is temporary data. It's only needed for when the user who has placed that order to actually know where in relation the delivery person is to the front door, right? Once that order has been placed and then has been accepted, that data is pointless. There's no point in capturing the points of the GPS, storing that anywhere. That becomes redundant data that gets removed. Also, we could be playing around with, say, data that connects perhaps related products together, or recommendations that are related to a single person but always gets refreshed based on the latest purchases. And then once a purchase has been placed, maybe we can store the data in a relational database, the data that has been offered to that person, so we can then see what was actually decided if someone actually click the add to cart, that kind of stuff, when we're upselling. But during the process of upselling, during the process of being in that journey, there is no need, in my opinion, to have that as relational data, because it's meaningless until the point of, I have selected this as an additional item in my cart. Same goes for reviews, right? If we've got a review, one thing NoSQL is good for is that if the data doesn't exist, you're not going to break the system. So if Deliveroo suddenly dropped all of its reviews, Deliveroo is not going to break. However, if the relational database breaks, then you're in a world of pain. So what a lot of people do is they look at the data that they're using and they're going, well, actually, this isn't necessarily business critical data, and so we're going to farm it off to NoSQL. Now, that doesn't mean that the data has any less importance or significance over the relational stuff. It just means that it's sort of, dare I say, secondary to the user journey, right? Okay, so this Amazon product that I'm reading here, that I'm looking at has 1,000 reviews, and yet I can only see the first 20 of them. Is that a problem? I'm not going to go through 1,000 reviews, am I? And also, NoSQL, as I've kind of alluded to, can be used as an interim. Again, we're going back to that Deliveroo example of the person going from A to B on their push bike to get to the front door. That is interim information. Also, the interim information of recommending a user a product whilst they're going through the checkout journey. And then when they click on the button to add that to the cart, that information is crucial to know what that product was and to know when they added it to the cart. But the rest of the products perhaps aren't as relevant, right? It is a question that one has to ask when they come to deciding, how is this data going to be stored? What is the database management system that I need to use to manipulate this data? And you got to ask yourself some really hard questions. Is this data relational? If it is, then definitely put it in SQL. If it's not, or if it's fluid, if it's flexible, if it warrants the need to use NoSQL, then explore it. But be aware that it is very different. Querying in NoSQL is very different. Another database that I've used that I haven't mentioned here is SQLite. I suppose we should talk about that, because SQLite, being another structured query language, is fantastic because it's in a single file that you can use, and you can put that on a mobile phone. When you've got an app and you're storing data, sometimes that goes to SQLite, and then when it's phoning home, to a server somewhere that is in the cloud, then it would perhaps pull the local storage, which is the SQLite data records, and then send that up to the server via an API. Again, interim data, local storage.